Our focus for today's video is we're going to be looking at common relationships between two angles. So we're going to be looking at adjacent angles. We're going to talk about the angle addition postulate. We're going to look at complementary and supplementary angles, and we're going to look at vertical angles in this video. Adjacent angles are two angles in a plane that have a common side and a common vertex. We have three requirements for adjacent angles. So the first thing is they must share a common vertex point. So here are my two angles, angle ABD, angle DBC. So the common vertex, they do have that. That is the point B is the common vertex. They have to share a common side or a common ray. In this case, both of these angles share ray BD. They share that ray. And then the angles cannot overlap with each other. So change colors here. If I look at angle ABD, that's this angle. If I look at angle DBC, that's this angle. You see how there's no overlap between the two angles? They're side by side, but they do not overlap. So those three requirements must be met in order to have adjacent angles. Do angle 1 and angle 2 in this example, do they represent adjacent angles? Yes, if it meets all three requirements. If it's no, can you tell me which requirement or requirements it does not meet? Well, on this one, you should have got no, because you look, here's the vertex for angle 2, here's the vertex for angle 1, it's already no good. Do they share a common side? They have a common side, but officially, this ray goes this way down, right? And the ray for this angle is going up, up, and away. So they're not really even the same ray. The angles do not overlap. It doesn't meet that requirement. So you could make an argument here if you just look at the side, had a common side. It has to meet all three requirements in order to be adjacent. How about these two angles? Are they adjacent angles? The answer is no. Again, they don't share a common vertex here, right? They're side by side, but they're not connected. No common vertex, so that's no good. They don't share a common side. They don't have a common ray at all. They don't overlap. That works. But again, it has to meet all three requirements. How about angle 1 and angle 2 in this example? Are those adjacent angles? Yes, or if no, what requirement do they miss if it's no? Well, let's see. Do they have a common vertex? Yes, has a common vertex. Check. Does it have a common side? No. Angle 2, it's a ray going this way, right? Angle 1 is a ray going this way. That's not a common side. So that is not a common side. And then these two rays are obviously not common. So this one is no good. Do the angles overlap? No, they don't overlap. In other words, there's no interior points in angle 1 here that are also in part of angle 2 and vice versa. So the reason why these are not adjacent is because they don't have a common side. How about angle 1 and angle 2 in this example? Are those adjacent angles? Yes or no? All right, on this one, we should have come up with yes. They share a common vertex point? Check. They share a common side? Check. And they don't overlap? Check. So it meets all three requirements. Those are adjacent angles. All right, the angle addition postulate. First, I want to define postulate. A postulate is a statement mathematicians accept as true without proof. So something like all lines go on forever. That mathematicians accept that as true, but we never looked at a line going on in space. All lines are straight. That is accepted as true without a formal proof of that fact. So that's what a postulate is. The one we have today is called the angle addition postulate. And what that says is if I have an interior point here, it says interior point P, and that's in between this angle RST, then the measure of angle RST has to be equal to the sum of these parts. So RSP and PST, those two angles, have to add up to the whole. So I like to say this postulate is basically the sum of the parts equal the whole. So if you have adjacent angles here making up a whole angle, those two parts will equal the whole each and every time. And that's without proof. We accept that. It's a postulate. So I want you to apply the angle addition postulate here for our first example. What's the measure of angle ABC? Did you come up with 100? So measure of angle ABD is 60, and plus the measure of DBC is 40. Those two parts equal the whole ABC, which is 60 plus 40 is 100. All right, so on some algebra here. Can you write me an algebraic equation to find the value of x in this problem? It says, given the measure of angle FJH, that's this entire angle, is 168 degrees. Then they want you to find the measure of FJG. But for now, I want you to focus on how would you write the equation just to solve for x. So we know the parts equal the whole, so that's how we write our algebraic equation, right? 6x minus 15 plus this x plus 8. And what does it equal? The whole, which is 168 degrees. Now I did the algebra for you here. We solved this, and we get x is 25. Now my question for you is, how would we find the measure of each angle? Or in this example, how would we find the measure of angle FJG? What would you do? All right, I'm hoping you said you'd use substitution, right? So we know if x is 25, if I want to find the measure of FJG, I just go, boop, substitute 25 for x right there. That's what we did over here. Here's the work. So it's going to be 6 times 25 minus 15. You get 150 minus 15. So the measure of angle FJG is 135. Then if I wanted to find this angle, I'd either go 168 minus the 135 would tell me the answer, or I take that 25 and substitute it for x here and go 25 plus 8. Gives you 33 degrees. Complementary angles is something I hope you have on your hard drive already. It's simply a pair of angles that have measures that add up to exactly 90 degrees. The two angles do not need to be adjacent. So that's why I give you, these are adjacent angles that happen to add up to 90 degrees. How do we know? The classic right angle we know is 90 degrees, and the angle addition postulate, right? These parts equal the whole. Here are two angles that are not adjacent, but they do add up to 90 degrees, so we call those two angles complementary angles. All right, can you figure out the measure of x in this problem? I'm hoping you got 28 degrees. You probably just did it in your head. You probably went 90 minus 62. You pulled out your calculator and did it and got 28 degrees. But I want you to show you the algebraic equation as well, because a lot of times I want you to show your work, and this is how you show your work. X plus the 62 equals 90 degrees. Next example, they want you to find the measure of each angle, angle LOM, this top angle, and angle MON, the bottom angle here. And we know they're complementary angles because it's a right angle here between them, the angle addition postulate. So how would you just write the equation to solve for x? All right, I'm hoping you told me you would go 2x plus 46 plus 3x minus 6 equals 90 degrees. Again, this part plus this part equals the whole. And then we'd solve for x. You get x equals 10. And then we're going to just use substitution into the expressions in order to get the degrees. So 2x plus 46, you substitute 10 for the x, and we end up getting 66 degrees. We substitute 10 in for x on the other expression, 3x minus 6. Solve that, and we get 24 degrees. So 66 degrees, we can check it. Plus 24 degrees, does that equal 90? Yes, it does. Check. All right, supplementary angles. A pair of angles that measures that add up to exactly 180 degrees. The two angles do not need to be adjacent. So just like complementary angles, two angles add up to 90. Supplementary angles are two angles that add up to 180 degrees. Students oftentimes mix those two up when they're first learning how to do this. So you want to make sure you get that down. Complementary add up to 90. Supplementary add up to 180. And again, you need to remember this. It's two angles that we're talking about. It's not 3 angles, 4 angles, 5 angles that add up to 180. It must be only two angles that up to 180. Those are supplementary angles. All right, so our first example is find the supplement for a 121-degree angle. So here's the 121-degree angle. They're telling us when they say find the supplement, they're saying that these are supplementary angles. Okay, so they're telling us that those add up to 180 degrees. So go ahead and figure out this missing angle here, angle ABD. So I'm hoping you came up with 59 degrees. You just probably went 180 minus 121. Again, I can show my work with algebraic equation, x for the question mark there. So x plus 121 equals 180. I subtract 121 from both sides, and that's how we get the 59 degrees. All right, given two angles are supplementary, and the largest angle is 12 degrees less than 5 times as large as a smaller angle, what is the measure of each angle? So I want you to write the equation, the algebraic equation to solve this problem. I'm going to help you get started here. I want us to all define x the same way. So we're going to define the smaller angle as just x. Now, I need you to think about how you're going to define the large angle, given that they tell you it's 12 degrees less than 5 times as large as a smaller angle. If the smaller angle is x, what's the largest angle in terms of x? Write the equation. All right, this one might have been a bugaboo for many students. This is usually a little bit more of a challenge. So you had to define the largest angle. So it says it's 12 less than 5 times as large. So see how the English is written, 12 less than 5 times as large? But when we actually do that algebraically, when we write this out, we got to think about the order of operations. So we're going to do multiplication before we do addition and subtraction, right? So we're going to say 5x. 5 times as large as the smallest angle, right? So 5 times that, and then we're going to subtract 12 after we do that. So because the order of operations, it doesn't follow the English. All right? So then your equation would be x plus 5x minus 12 equals 180. Then we would solve this. We combine like terms. We get 6x minus 12 equals 180. We'd solve and end up getting x is 32 degrees. And then if we want to know the measure of each angle, well, x is the smallest angle, so that's what we defined it. So the smallest angle is 32, but they asked us what's the measure of the largest angle. We either go 180 minus 32, or we can substitute into our expression, right? 5 times 32 minus 12, and we end up getting 148 degrees. All right, the next common pair of angles you'll see in this class are linear pair, a pair of adjacent angles that are supplementary and form a line. So it's basically you'll have a line or a line segment, and you have two angles on one side of the line. That is called a linear pair, and these are always supplementary. They always add up to 180 degrees. So you just need to know if you recognize a linear pair, then you know that they are supplementary angles. So our example is really similar to what we just did with supplementary here. Here we'd recognize a linear pair. What's the value of x? And you probably just did 130, subtracted that from 180 degrees, and you got 50 degrees. But here's the algebra. Our unknown x plus 130 equals 180. Again, parts equal the whole, right? So think about this. The x plus the 130-degree angle, well, that's the same as this entire angle, right? Those two parts equal the whole. Okay, so that's a linear pair, and that's how we find a missing angle. All right, here's another linear pair. Can you just write the algebraic equation for me for how you'd solve for x? So on this one, you'd go 2x plus 3 plus x minus 6 equals 180 degrees. And we'd solve for x, and we get x is 61 degrees here, right? We combine like terms, 3x minus 3 equals 180. We'd add 3 to both sides, so 3x equals 183, and that's how we get 61 degrees. Then if I asked you to tell me what's the measure of the acute angle, well, the acute angle is the one that's less than 90, so that would be this one on the right. You substitute the 61 in for x and get 61 minus 6, and you end up getting 55 degrees. If I said find the measure of the obtuse angle, well, you know it's this angle. So then you would simply substitute 61 in for x and simplify that, and you get 125 degrees. All right, our last relationship for today. Vertical angles. Vertical angles are a pair of opposite angles that are formed by two intersecting lines, vertical angles are always congruent. It means they have the same measure. So if you think about this, anytime you have two lines that cross, it creates 1, 2, 3, 4 angles. Okay? The angles that are opposite each other are what we call vertical angles. So this one and this one are vertical, and this one and this one are vertical. And vertical angles are congruent, so they have the same measure. So this angle X is the same as this angle X. This angle Y is the same as this angle Y. And here you can see with the angle measurements in there, 75 degrees are vertical, and the 105 and the 105 are vertical. All right, this should be a quick one. Given two angles are vertical angles and one of the angles measures 127 degrees, find the measure of the other vertical angle. All right, here's the other vertical angle. It's X. The unknown measures the same as the one opposite to it, so you should have said 127 degrees. Example 2, given two angles are vertical angles and one of the angles measures 131 degrees, solve for X within the diagram to the right. So here are the two vertical angles. How would you set up the equation to solve for X? So to solve for X, we'd simply say 4X plus 7 equals 131 degrees. Subtract 7 from both sides, we get 4X equals 124. We divide both sides by 4, and we get X equals 31 degrees. All right, I've been throwing a lot of different academic vocabulary at you today and yesterday with angles. I'm hoping a lot of this was prior knowledge for you, but let me know, how are you feeling with this material? Do you have any points of confusion you want me to address in the classroom?